Okay, we're going to start working through solving systems of equations using substitution. So, like I mentioned in the intro video, graphing systems and comparing tables, there are good ways to see the solutions of a system of equations. However, it's not always easy to graph something, and also this is really only just an approximation. So looking at a graph is going to allow for some error because we might not graph it totally perfectly, or it could just be off a little bit. So in order to find the exact solutions, we'll need to figure this out algebraically. So one of the ways we can do that is through substitution. So what I think is the best way to kind of introduce you to this is to do an example. So let's imagine that on a highway, there is a police officer and he sees a motorist run a red light at 50 miles per hour, and he starts to pursue him. At the instant that the police officer passes through the intersection at 60 miles per hour, the motorist is 1 mile down the road. So if both drivers maintain a constant speed, so the police officer stays at 60 miles an hour and the motorist is going at 50 miles an hour, when and where will the officer catch up to the motorist? So we're going to first identify the different variables, the dependent variable and the independent variable. And then we'll write a system of equations to model this situation. Then we're going to solve the system of equations by using the substitution method. And then we're going to explain what that solution actually means. Okay, so what I did is I started writing down the different pieces of what was given to us in this problem. So we know that this motorist was going 50 miles per hour and the police officer was going 60 miles per hour. We also know that when the police officer was at, let's call this like ground zero, he was at 0 and going 60 miles per hour, the motorist is 1 mile ahead, going 50 miles per hour. So our first step is to come up with the independent variable and the dependent variable. So the independent variable is going to be, we're going to set that as the time that they're driving. So we're going to say that that's t. So, and it equals, so the amount of time in hours when that each person is driving. So time in hours. And we'll say that when t equals 0, that's when the police officer is passing through this intersection. So right at that moment, that's when we're going to start counting. And then d is going to be our dependent variable. And d is going to represent the distance each car is from the intersection, the distance from intersection. Now what we want to do is set up a system of equations. So again, that just means a couple of different equations that will represent, that will model this situation. So we always start with our dependent variable. That's going to be on one side of the equal sign, d equals. And let's start with the motorist. And then we'll do the police officer. Police. So the motorist's distance from the intersection, well, we know he starts 1 mile away. So that's going to be like that starting point. And then for every hour he drives, he'll be another 50 miles from that intersection. So we represent that by saying 50t. 50t. This again being the amount of hours that they're driving. So after 1 hour, he's 50 plus 1 miles away. After 2 hours, he'd be 100 plus 1 mile away. Right? And then for the police officer, so he starts at 0, so I don't really need to put anything there. It's just going to be his speed, which is 60 miles per hour. So 60t, right? Now this next piece is going to be where this method of substitution comes in. Substitution. So what we're going to do, so up here in this first equation, I have d equals 1 plus 50t. My second equation, I have d equals 60t. So what I can do is I can substitute, since these are two different variables we have. So it's not possible that I can solve for d, but it's not really telling me anything because it's only telling me it in terms of t. So I want to try and solve this system of equations so that I have a value for d and a value for t. So what I'm going to do is I'm going to substitute, I'm going to plug in this 60t in for d. Okay? Plug this in for that. And then I solve for t. And then I can plug t back in and then solve for d. Okay? So just follow along for now. Right? So we're going to plug in 60t in for d. So that gives me 60t equals 1 plus 50t. All right, and now I can solve. So my first step is I want to move my terms around so that all the terms with a variable are on one side of the equal sign, and then my constant term, that 1, is on the opposite side of the equal sign. So what I'm going to do is I'm going to move my 50t so that it's over here with the 60t. Since we're adding 50t on this side, the way I undo that, the way I move that portion, is I do the inverse operation. Inverse operation of adding 50t would be subtracting 50t. And if I subtract 50t from this side of the equation, then I also need to subtract it from this side of the equation. I combine these two lines together. 60t minus 50t gives me 10t, and that equals 1. And then this 50 minus 50 cancels out. Now I'm left with 10t equals 1. So there's an invisible multiplication sign going on in between the t and the 10. So I know that I have to undo multiplication by using the inverse operation of multiplication, which is division. I'm going to divide this side by 10, which means I also divide this side by 10. Over here, these 10s cancel out, and I'm left with t equals 1 over 10. 1 over 10. Let's write that as a decimal. That's going to be 0.1. 0.1. So now what I can do is I can plug this 0.1 back in to really either one of those equations, and I'd get my answer for d. Let's pick this one because it looks a little easier. So I'm going to get d equals 60t, but I'm going to plug in 0.1 in for t. So d equals 60 times 0.1, which equals 6. D equals 6. Right, so I just found my solution to this system of equations where t equals 0.1 and d equals 6. So now the last piece is kind of putting this back into context. of our situation that we were dealing with. So we were looking at these two drivers and we were looking where they were going to meet. T was equal to the amount of time that they were driving, and then D was equal to their distance. So where they met is this solution to the system of equations. So where they met, see, am I going to run that from? So where they met was at 6 miles. They met 6 miles past the intersection. After, that's 0.1 hours. And we can easily figure out what that would be in minutes. All we have to do is just multiply that 0.1 times 60, which gives us 6 minutes. So after 0.1 hours or 6 minutes, right? We'll do some more practice problems just like